Gravitational waves are invisible ripples in spacetime caused by certain celestial events. To better understand this concept, think about sitting by a calm lake on a pleasant evening and throwing a pebble into the water. What happens? You will immediately see ripples spreading in all directions from where the pebble disturbed the surface. This process is similar to how gravitational waves operate. Gravitational waves are ripples that occur in spacetime. Spacetime, in simple terms, is a concept that involves the union of space and time. It combines the three dimensions of space with the fourth dimension of time. We have made a detailed video explaining spacetime, which you can check out in the description. Most gravitational waves are generated during events in which celestial objects move at very high speeds. Examples of such events include the asymmetric explosion of a star, known as a supernova, two stars orbiting one another, or the merging of two black holes. Here's how it works. When these massive celestial objects, such as neutron stars or black holes, move, they distort spacetime. This is similar to how a thrown pebble disturbs the calm surface of water. As these disturbances in spacetime occur, they travel across the universe at the speed of light, reaching other celestial bodies, such as planets and satellites. We have been aware of the concept of gravitational waves for more than a century. One of the scientists credited with this groundbreaking idea is the eminent physicist Albert Einstein. In 1916, he proposed that when two celestial bodies, such as stars or planets, orbit each other, they create disturbances in space, similar to ripples. In 1974, astronomers Russell Hulse and Joseph Taylor discovered a binary pulsar located 21,000 light-years away from Earth. After observing these powerful celestial objects for several years, they noted that the two stars were gradually moving closer together, consistent with the predictions of general relativity. However, at that time, we had not yet detected gravitational waves. Detecting gravitational waves is quite challenging because the events that generate them do not always produce strong waves. At times, they only generate weak ones. Additionally, these events typically occur millions of miles away from Earth. By the time the gravitational waves reach us, they have significantly weakened, making their detection difficult. It wasn't until 2015 that we finally detected gravitational waves. This achievement was made possible by LIGO, Laser Interferometer Gravitational Wave Observatory, a highly sensitive instrument designed to observe these waves. The detection was due to the collision of two black holes that occurred nearly 1.3 billion years ago, which generated waves that traveled back to Earth. This historic discovery opened up an entirely new way to observe the universe. Understanding the importance of gravitational waves can be likened to tuning into a cosmic news broadcast. While we can observe stars and galaxies with powerful telescopes that capture their light, dark and invisible cosmic events, such as black hole collisions, are extremely challenging to detect. This is where gravitational waves become essential. They offer insights into these elusive happenings across the universe. Gravitational waves provide a new way to learn about cosmic occurrences, enhancing our understanding of the universe and its evolution. They allow us to evaluate massive celestial objects by offering information about their masses, spins, and distances, data that traditional observational methods may not be able to capture. Overall, gravitational waves help us address fundamental questions about nature, space, and time. So, the next time you throw a pebble into a calm lake and observe the ripples spreading outwards, remember that you're witnessing a phenomenon similar to a cosmic event that reveals countless secrets about our universe.